Okay, so today we're going to look at the second part of section 1.1, which is on multiplying.
This might be a first. I think every kid has their notes.
That's awesome.
That's like the same. I'm mindful right now.
Okay, so what two operations did we use yesterday? Someone remind me again, Yusef?
Adding and subtracting.
Adding and subtracting. Okay, so yesterday, addition and subtraction. Okay, that's just a review from yesterday, that's all. Okay, today we're going to look at multiplication and division. Okay, so we talked a little about the reciprocal in the warm-up, so you're going to see that come up when we talk about multiplication. Alright, so we've done the addition property of equality, we've done the subtraction property of equality. Anyone think they can tell me by now what the multiplication property of equality is? Based on the two we did yesterday?
Is it similar?
Yep, it's exactly the same thing. You change one word. Yep.
Like if there's a problem, if something's being divided, you multiply.
Multiply where?
What's being divided, like the.
Okay. Can anyone expand on that a little bit? What do we always have to do anytime we work with an equation? We have to make sure if we do something, we do it where? Yep.
If you do anything to either side of the equation, you have to make sure you do it to the other side.
Yeah, we have to do it to both sides, whether you're adding, subtracting, multiplying, or dividing. So this just says you can multiply both sides of an equation by the same number. Now, there's only one number you can't multiply both sides by, and that would be 0. How come? Why can't you multiply both sides of an equation by 0? Like if you had something like, let's just say 2x equals 12. And you say, oh, let's multiply both sides by 0. What happens if you do that? Yeah?
You get rid of both sides entirely.
Yeah, you'd wipe out both sides. Okay? If you multiply that by 0, that's gone. If you multiply that by 0, that's gone. 0 times anything is what? 0. Now you have 0 equals 0. You've lost everything. Okay, you lost the letter, you lost the numbers. So you can't multiply both sides by 0 or you lose everything. So let's look at an example. So here's an example of equivalent equations. The top one says x equals 3. And then what I did is I multiplied both sides by 2. Okay. What's x times 2? How do we write that? We normally don't say x2. How would we write that?
The variable first.
How about Dave? You write
Next to x.
Yeah, 2 next to x. And how would you pronounce it if you were reading it?
2x.
Perfect. 2x. And what about if you multiplied the right side times 2? What do you get?
6.
6. 2x and 6. Okay. 2 times what gives you 6?
3.
3. And it says up above, x equals 3. These are equivalent equations because the top equation says x equals 3. The bottom equation also has an answer of 3. They're the same thing. So as long as you multiply both sides by the same thing, you're good. And we're same for division. All right, so we've talked a little bit about coefficients. What does coefficient mean?
You skip a slide now.
No, I don't think so.
All right. Sorry.
What's coefficient?
It's a simple way to say that.
Have a guess? Yeah, Chris?
The number that comes before the letter.
Yeah, it's the number that comes before the letter.
Yeah, the number attached to the variable.
Is this the slide you were thinking of, Mr. Roy?
No, say no.
Okay.
I'll do that one if you want.
So sometimes we might have an equation that looks like that. Okay? We have a fraction, okay, in front of the letter. We're not going to do that one yet. I'm just showing you what example 1b is going to be. Well, we want to get rid of this entire fraction, okay, the whole thing. And when we did the warm-up, we talked about something that could get rid of a fraction. What was that word we used in the warm-up? If you multiplied a number by its blank, it canceled out and became 1. Yeah, Hager? Reciprocal, exactly. So, let's talk about some examples with reciprocal. So, if the number in front of the variable is a fraction, we're going to multiply both sides of the equation by the reciprocal. That's going to cancel it out. So let's just practice a couple more like we did in the warm-up. So let's suppose I had the fraction 5 halves. What's the reciprocal of 5 halves? Yep, Gigi? 2. Over?
5.
Over 5. So 2 over 5. And that's it. Now we've mentioned it a couple times, but if the number starts as positive and you find the reciprocal, what kind of number do you get? If it starts positive, the reciprocal would be, Ellie?
Positive?
Positive. What if it started negative?
It would be negative.
It would be
You're
negative.
not changing the sign.
Yep, so the sign never changes. So what can I copy down right away here? My number starting is negative. It's going to finish as, Yusuf?
Negative.
Negative. Let's just put that down right away. Now we got to find the reciprocal. What's the reciprocal, how about Melanie? What's the reciprocal of negative 3/4?
Negative 4/3.
Perfect. Negative 4/3. Okay, that's 2 divided by a. So this time now we have a variable. We don't know what a is, but it doesn't matter. Still do the same thing. What's the reciprocal of 2 divided by a? Yeah, Miguel?
A over 2.
A over 2. Yep. 2 divided by a becomes a divided by 2. How about b over c?
Two letters.
So this is just kind of the general case. You don't have any numbers at all. Mary?
C over B.
C over b. Okay, the point we're trying to get at is you just flip it. That's all you do. Take the top and the bottom and flip them. Okay. So you guys copied some stuff like that down in the warm-up. Any question on finding a reciprocal? And we also said, what number can you always put on the bottom of a fraction if you need to make something a fraction to flip it? We did that in the warm-up too. Donovan? You can always put a 1. Always put a 1 on the bottom of a fraction.
Guys, as far as the stuff that you're going to need to write in your notes, the steps are going to be similar to yesterday. All right? So think back to yesterday, right? And you actually have your notes right in front of you, right? What was the first thing we had you do yesterday? Savannah? Find the variable.
I apologize for the interruption.
No.
Any freshmen?
So again, just like Savannah said, right? We're gonna find, but this is different, right? So now we want to find the number with the variable that's attached to it. So like 2x, 3/4 x. So on your notes, right on the bottom now, this is gonna be your first step. So when I look across this room, I should see everybody writing now. So on the bottom half of your notes there, in the first bullet, the first thing you want to do is you're going to find the number with the variable attached. And again, that could be a fraction, right? It could be. Not always, but for some of these that we do, you may get a fraction attached to the variable. All right. Next. Oh, and there's 2 little bullets underneath. I'm just gonna go down. You guys can write it all at once. All right. This is gonna help you decide what operation you're gonna use. All right. So you'll multiply both sides of the equal sign by the reciprocal if there's a fraction attached, right, to the variable. All right. Those little dashes below the first bullet, you want to write, again, if it's a fraction attached, you'll multiply both sides of the equal sign by the reciprocal only if there's a fraction attached. You with me, Jake? You know what I'm talking about? So here on your notes. Yeah, guys, if you want to write it underneath that, I think that the notes are a little bit different. If you wrote it under that first, on the second bullet, that's fine. If you skip that second bullet and wrote it on the little, with the little indents here, whatever you want to call it, that's fine too. I don't care, as long as you have the steps. And again, you guys may know. You guys may know how to do this anyways, but again, it's just good to talk about the steps. So, like I said, first thing, if there's a fraction attached to the variable, flip it and multiply both sides by that number, by the reciprocal. We'll divide both sides of the equal sign by the number attached to the whole number. So fraction, flip it, right? Reciprocal, multiply both sides. Whole number, divide by that number, whatever number is attached to the variable, on both sides. That's how it works. Guys, most times, what we're talking about right here, divide, most times, 80-85% of the time, the stuff we do this year, that's going to be the last step. If we're working with equations, 80 to 85% of the time. Very rarely, do we have you guys working with fractions? Sometimes it does happen. But again, majority of the time, your last step when you're doing this stuff is going to be dividing. You're always going to divide by the number that's attached to the variable on both sides. You with me, Jay? Alright, does anybody need any more time with this? Am I good? Alright. And like I said, a lot of you guys may know, again, today's stuff, again, it's basic. It's one step. Alright, you're either multiplying or dividing. There's no more than that. Tomorrow, when we get to 1.2 part 1, we'll have to do 2 steps. Maybe add or subtract, and then multiply or divide. And then when we get to Thursday, we'll do variables on both sides. Alright, so you have to move things twice. You have to move the variable to one side and the other, and then move the whole number to one side and the other. Alright, so we're kind of building on these steps each day. Alright, good with this. And then, next thing, we're going to simplify both sides of the equal sign. That means that we're going to, when we simplify both sides, we're either going to add, or we're either going to subtract, we're either going to multiply, or we're going to divide, depending on what we have. Whole number, divide. Fraction, multiply. Alright? So we'll simplify both sides of the equal sign. And then last thing, again, only if we have to, we will check it. Alright? Again, on the test, we'll tell you, solve and check. If it's solved, don't do any more work than you need to. Just solve it. You don't have to check it, don't do any more work than that. Alright? So there's our steps. People are okay with those? Alright, let me scroll down a little bit here. Alright, so so to the right, so you guys just draw all your steps. To the right of the steps on your guided notes over here, you guys had a little space for example 1A. Alright? So I'm going to scroll up just a little bit so we can see the steps. So, Matt, what's the first step? What's the first step up here?
Oh, have the number with the variable attached.
Do you see it?
Yeah, the fourth.
Okay, so is it a whole number or is it a fraction?
The fraction.
It's a fraction, right? What's the fraction? Can you tell me?
X over.
X over 4. Okay, so we've identified that. Here's our variable, the x. Good. Alright, so I'm going to call, you don't have to write this. I'm going to call this option A. I'm going to call this option B. Alex, am I going to have to use option A or option B? Am I going to multiply, which is option A, or am I going to divide, which is option B? A. All right, I'm going to multiply because what do you see there that tells you you have to multiply? What do you have there that tells you you have to multiply? Alex, what do you have there that tells you you have to multiply? A fraction, right? Good. Nice job. So we know we're going to multiply. I'll put a little dot. Magellan, what am I going to multiply by? Yeah, which would be what?
4.
I wouldn't put x, I'm just going to put 4 over 1. I don't want to put the double x, so that'll screw me up. So I'm going to put 4 over 1. Anything else? Is there anything else I need to do? Mary?
Multiply the 7 times.
Multiply the negative 7, all right, by 4. Again, I can do it. If you want to just put 4, that's fine. If you want to put 4 over 1, that's fine too. I'm totally up to you how you want to do it, all right? So, on this left-hand side, where I had the fraction originally, Catherine, what's going to happen on this left-hand side where I had the fraction originally? Why did I multiply by 4? What do I want to get? By doing this, what am I going to be left with? Just the x, right? These things cancel out. I'm multiplying by a fraction because everything's canceling out, and I just want the variable left. So on this side, I'm just going to have x. On that left-hand side, how about Melanie? Am I going to have a negative or a positive? Negative, right? Again, we're not adding, if we were adding or subtracting this, we will get a negative because 7 is bigger than 4, but we're multiplying. Negative times a positive is a negative, right? Haley, what's the number going to be? I know it's negative, but negative what? Negative 28. Again, there's your answer. But it's asking you to check. So, here's my equal sign. To the left-hand side of the equal sign, what am I going to write? Ellie?
28. Negative 28.
Negative 28. Anything else?
9 equals negative 7.
Okay, I like that.
Times 4.
No, again, the stuff in black was the original. Right, the stuff that's up here in black was the original. The stuff in red is when I did the solve. Mary?
Negative 28 over 4.
Negative 28 over 4, right? So I'm taking this, I'm taking that negative 28, and I'm plugging it in for x. So it kind of look like this. X 4 equals negative 7. Once I plug things in, it'll look like this. Negative 28 over 4 equals negative 7. So here's my original, this is my original, right? It becomes, by plugging in, x becomes negative 28 because that's what I solved for. There it is written out, right? Same thing I've written down here. I'm just showing you guys here how it changed from x to negative 28 because, again, I solved for x, I got negative 28. Now it says, we'll do the math on that right-hand side, left-hand side. So it says negative 28 divided by 4. My answer is going to be positive or negative? Ellie?
Negative.
Negative. Negative what, Ellie?
7.
Negative 7 equals negative 7. My numbers match up, right? Same on one side, same on the other side. Check, I'm good. Again, don't check unless you have to. Again, when we get into the stuff next week, we're not going to have you guys check. All right? We just want to see you guys understand the skill of plugging the number in for what you solve for and checking it. Next week, you don't have to do this. And all the problems on the test, you won't have to check all of them. Maybe if there's 13 questions, maybe you'll check 5, something like that. Good, so we did that. Any more on this page? I don't think so. Oh, all right, next page. All right, so on your notes, right? Now we're on that bottom little strip of your notes. You have space for example 1b. Some of you guys, this is the one we showed you earlier, to show you that you might have a fraction attached. Some of you guys may have already written it down, right? Most of you probably haven't. So I'll give you a little bit of time to get that copied down. And then we'll talk about solving. And so similar to the one we just did, all right, but it just looks, I mean, obviously the numbers are different and stuff like that, but the fraction itself looks a little bit different. What do I mean by that, Mary?
The variable isn't in the fraction.
Yeah, the variable isn't part of the fraction. Before we had what, x over 4, right? Had x over 4. You can have that, you can have this. It doesn't matter. Either way works. All right? So step one, Paige, step one's kind of done for us. Why is that?
No, because we're already found the number.
Yeah, and what's the number?
2/3.
And the number attached to the variable, which is y, is 2/3. Great. All right. What can I do now? What do you think, Nathan? What can I do now? So now I've identified the number attached to the variable. Now I'm to that next point where I have a choice of what I have to do. I have a choice depending on what's attached to the variable, right? So what do I have attached to the variable? A whole number or a fraction? Okay, so when there's a fraction attached, what do I have to do? What operation do I have to use? Multiply. Nathan, do you know what number to multiply by?
3/2.
3/2. Is that it?
Just doing
Both sides, good. 3/2. Here's my equal sign. Dylan, on this left-hand side, where I had the 2/3, I did the multiply by the 3/2, what's left?
Don't take.
Yeah, exactly, you're right. Got it? We, again, understand, we're doing this to get rid of the fraction. That's why you're multiplying by the reciprocal, so you can get rid of the fraction. We don't want to deal with fractions. That's why we're doing that. This just gets wiped out. This becomes y. That's why we did it. Not just for the fun of flipping the fraction and saying, hey, cool, I can do the reciprocal, yahoo. No, we're not doing that. We're doing it so we can get rid of the fraction. We don't want to deal with that. All right? On the other side, you got options. All right? What can I do with that 6 to make it a fraction? Mary?
You can put it over 1.
Put it over 1. What's one way I could solve? Ellie, thank you, but I'm going to call someone else, but thank you for volunteering. Somebody else. Matt?
You can simplify it, so 6 is 3, and then 2 is 1.
So what Matt's saying is, he knows that he's looking cross. He knows that 2 goes into 6. That's why he crossed it out and made it a 3. He knows 2 goes into 2 one time. At this point, Matt, what am I going to do?
You can multiply across.
Multiply across, right? Top by the top, bottom by the bottom. If I do that, what do I get, Matt? 9 over 1, which is really 9. Anybody know another way? So I'm just going to show you over here. So we had 6 over 1 times 3 over 2. Anybody know another way? Allie?
You could do like 6 times 3. And
Exactly.
1.
We could do what like Matt did, what Matt did in like step 2. All right, so we knew these. Then at this point, we multiplied the top by the top, bottom by the bottom. You could do the same thing here to start. 6 times 3, 18. 1 times 2, 2. Now, instead of simplifying in the first part like Matt did, I'm simplifying in the last part. So I have 18. What's a fraction really? What is that showing? Allie?
A variable over a number.
Okay, but what operation is it representing?
Division.
Division, right? This really means 18 divided by 2, which is what? 9. Either way works. You're not wrong. You can simplify. Again, you may want to simplify at the beginning, but again, sometimes it's hard for people to see this. If you do it like this, just make sure at the end you simplify. We don't care how you do it. We're not going to take points off for doing it either way. As long as you got it simplified to 9, don't care how you got it. Right? So our final answer will be y equals 9. It doesn't say it there, but let's check it. If I was going to check it, what am I going to write? How about... What am I calling it? Jake, do you feel that you can set this up to check it? Not sure. All right. How about Nicole? Do you feel you can set this up to check it? Not sure? Okay, I think people are saying no because they see a fraction there. All right? Gigi?
You would put the 2/3.
Put the 2/3. Agreed.
Then put in parentheses 9
Put in parentheses 9.
equals 6.
There you go. I think some people got nervous because they saw the fraction. It doesn't matter. Just plug the number. Wherever you see this letter, put that number. Right? Just because don't get nervous because it's a fraction. You can do it. All right? Now, again, I go back to kind of like what we did when I showed you with the fractions up here. You have those two options. What am I going to do with that 9? Obviously, I'm going to multiply. What can I do with it to make it look a little bit nicer? Ellie?
2/3 and 9/1.
I'm not going to add.
Times.
Times. But what can I do with that 1 to make it look a little bit nicer? Maybe have it make a little bit more sense. Aaron?
You could just.
Yeah. Let me say it again. What can I do with that 9 to make it look a little nicer and make the problem a little bit easier to follow? Anybody know? I got a whole number there, right? Matt? Put it over 1, right? Then I got fractions. Then I have fractions on both sides. So you have options here. You can go with Matt's option, all right? Or you go with the other option I showed you. So Matt's option is simplify at the beginning. The option I showed you, simplify at the end, all right? I'm going to go with Matt's option. I like it. It's faster, all right? I know 3 goes into 3. You're looking across to see what numbers go into what numbers evenly. 1 can't go into 2, 2 can't go into 1. I can't cross cancel those. Oh, I know 3 goes into 9 now. So I'm going to cross out the 9 and put what number above it? Savannah? 3. What about the 3? Nicole? Yeah, cross it out. Put a 1. You're looking for, when you do it like that, you're looking for numbers that go into each other even. Alright? And then at this point, what can I do? Top times top, bottom times bottom. 2 times 3, 6. 1 times 1, 1. 6 over 1 is really what? 6. 6 equals 6. Check, right? So again, when you have to check it, don't get freaked out because you have a fraction. Alright? For multiplying fractions, to make it look a little bit nicer and a little bit easier to follow, just put it over 1. That's all you need to do. You guys can do that. Alright? So that's example 1B. Questions so far? Again, it's all just one step, basic kind of stuff. Alright? So you want to do this part? I'll let you do this.
Thank you. All right. So now we're at our last property. Before I even show you the name of the property, what do you think the last property is called? Yeah?
What was the one we did before? Yeah, what we did before this.
Would it be division?
Division property
Of equality.
of equality, yeah. So division property of equality. What do you think, now we know the name of it, what do you think this property allows you to do? What do you think it says, Mary?
Divide and solve.
Okay, it has to do with division. Be a little more specific, Don?
Stuff equal by dividing.
Okay, missing something important that we've had in all of them so far. Something you've got to remember to do. Like if you divide, where do you have to do it? Ellie?
Both sides.
Both sides. So you can divide both sides of an equation by the same number and get an equivalent equation, but there's one number you're not allowed to divide both sides by. You're never allowed to divide by this number. Yep, Najela? 0. So you can divide both sides of an equation by any number you want except 0. But the key is you have to do it on both sides. Okay. Let's look at an example. So there's just an equation. It says x equals 8. If I divide both sides by 2, the left side would just be x divided by 2. What about the right side? What's 8 divided by 2? Yep. You said 4. So look at the equation we just made. What do you divide by 2 and get 4 as the answer? What, Dylan?
8.
8, exactly. So the answer to this bottom equation is 8. The answer to this top equation is 8. These are equivalent equations. Okay? So I just showed you by dividing both sides by the same number, you still get the correct answer. Unless you divide wrong. Okay? So just be careful. All right, so let's look at this one. Solve and check. Okay, 18 equals 3x. Now, is that a fraction in front of the way it's written right now? Is 3 a fraction in front of the variable? What do you think? How about Catherine? Is 3 a fraction? Not sure? You want to help her out? How about Paige? No, 3's not a fraction, right? There's no denominator there. It's just a 3. So we're not going to be multiplying by a reciprocal here. Okay, that's only when you have a fraction. What operation am I doing with the 3 and the x? It's 3 next to x, but if we can figure out what operation it is, then we do the opposite of that operation. Yep, Savannah? That's multiplication. So if we want to get rid of 3 times x, what's the opposite of multiplication? Yeah, David? Division. So we're going to divide. And what are we going to divide both sides by to cancel out the 3? Yep, Haley? 3. So we're going to divide by 3 and divide by 3. How about Laura? What's 3 divided by 3? You cross it out because what does it turn into? 3 divided by 3 is just
1.
Exactly. It's just 1. So we can cross it out. We get x on the right. And then on the left, if we can reduce, we always reduce as much as we can. And this one does reduce. What's 18 divided by 3? How about Alex? 6. Yeah, very good. So we get x equals 6. Okay, Ryan, am I good?
I'm writing down, I wasn't listening.
So I just wondering, are we done the problem? Are we all set?
Looks like it. You have to check it.
You gotta check it. So the directions say to solve and check. We didn't check yet. All right, so now we'll finish it up on checking. All right, so Bethany, to check that, what do I do with the 6? Or just in general, how do you check any problem? What do you always do with your answer? Not sure. Yusuf?
I have a question. Can't you just do like 6 times 3 and get 18 like as a checking? Like,
Yeah, that's how you check it. Exactly. That's what we're going to do.
Alright.
Yep. So, can people just, someone just kind of say what Yusuf just said, and that's basically what we're going to do. I just want to know what do I write down first. But then we're going to do what you just said. Mary?
You just would put the 6 in where the x is. You rewrite the equation
Yeah.
instead of 12.
Exactly. Just put the 6 in for the x. So we've got 18 equals, I'm going to put a question mark there because we don't know if it's true yet. I mean, some of us might, but we're checking it, okay, to see if it's true. So we got 3 times 6, and the question is that true? If it is, then we did it right. If it's not, then we got to fix it. We got to go back. Yep.
It would be right.
Yeah, 3 times 6 is 18. 18 equals 18. We're good. Okay, any questions on? All right. Do we have 3B? Nope, we go to 3D, and then we're going to look at, I think, a word problem.
We don't have 3D.
You don't have 3D? What's your next blank?
2A.
3A?
Yes.
2A.
2A.
Just did the two.
Well, 3A you should have just filled in.
Oh, yeah, 2A.
2A.
Put this one on the next blank you have available. And the directions are solve and check.
I think, guys, are most of you guys putting this in the 2A spot? Most of you guys putting this on your notes, on your guided notes, or most of you guys putting this in the example 2A spot? Okay. I just want to make sure when I make the reference sheet that I know that.
All right, so 5x equals 40. Okay. Anyone think they can guide me through what to do here? Yeah, Miguel?
Divide by 5.
Yeah, we're going to divide both sides by 5. Now let's do it out. On the left-hand side, 5 divided by 5 gives me... Oh, page? Cancels out because I get what? careful. No, 5 divided by 5 is not 0. If you had $5 and you give it out to 5 people, does everyone get 0? No, everyone would get how much? Exactly, 1. So 5 divided by 5 gives me 1. And I get x equals 40 divided by 5, Donovan?
8.
8. Very good. Okay. Ryan, are we all done? No, how come?
You gotta check.
Nice job. We gotta check it. So we're halfway done. We solved it. Let's check it. How about the jelly? How do I check it?
You plug in what x equals
Yep. Plug in what x equals.
into x and
So we got 5 times 8. And the question is going to be, does that come out to what they told us it should? 5 times 8, is that 40?
yeah.
We're good. Right, so very similar to example 3a. Okay. Any questions on that one? Okay. So when we see the word of, okay, when we do word problems, the word of usually means multiply. Like if I said to you 2/3 of 12, that means to do 2/3 times 12. So we've got that list of important words, so equals, is, decreased by, difference means subtraction. Well, of means multiply. Okay, so we'll finish up by looking at a, I think we have a word problem next that has the word of.
You just have
Guys, I think what it's doing, you don't have to worry about writing it down. You just kind of go over it.
Alright, so in example 4, it says, in the 2012 Olympics, Usain Bolt won the 200-meter dash with a time of 19.32 seconds. Write and solve an equation to find basically how fast he was running. So first thing, we have to know, does anyone know the equation for, it has a distance, it has rate, and it has time in it. Distance, rate, and time. If not, we're going to learn it right now. Yeah. Yep, so what's the formula though that has those 3 things in it? It has an equation sign in it somewhere. Anyone know? Yeah, here.
distance times rate equals distance times rate equals time.
Just not quite. You're close. Let's start out with distance equals, and then it's rate times time. So D equals RT. So D is your distance. R is your rate, and T is your time. Okay, so take a minute on your own and see if you can set that up. So look at the problem, see if you can find the distance, fill that number in for D. See if you can find the time, fill that in for T. And then the average speed, that's the rate. The question is to find that, so we don't know what R is. So you're just gonna leave that as R.
Oh, or could you do X as well if you wanted to, or should you do
We'll stick with R just because
Okay.
we used R in the formula. But just take a minute and fill that in and see if you can get R by itself. Now, you're going to need a calculator because it's a decimal. So don't worry about actually doing the whole problem out. Just write what you would do up until the part where then you type it in on a calculator. Okay, so just take a second and see if you can do that. Okay, so let's take a look. Let's start with D. Okay, what number did people fill in for D? You said?
200 meters.
Yeah, 200 meters. Whoops. So you got 200 meters equals, and then how about R? What did we fill in for R, Matt? Okay, so what did you do with it?
I just put R for now.
Yeah, exactly. We'll just leave R the same. So we don't have R. And then T, well, that's the time. So, Jake, do you see that problem where the time is?
19.32.
Yeah, exactly. 19.32 seconds. So there's our equation. And now we're going to need a calculator, but can anybody tell me what I would do to get R by itself? And then I'll use my calculator to get the answer. Ellie?
Multiply or divide. Would it be multiply or divide? Divide 19.32 by 200.
All right, so the two options we have out there are multiply or divide. Anyone think they can tell me for sure which one? Savannah? Yeah, we're going to divide. Because you can think of this as multiplying right here. We're going to divide. And again, something like this, we definitely don't expect you to do 200 divided by 19.32 by hand. So we'll just use our calculator. Yeah.
Is there one for the calculator, or do you want us real calculators like the scientific ones?
Yeah, when we have like a test or something like that, we'll get out the scientific ones. So for this one, you can just watch me. 200 divided by 19.32. Okay, so you get an answer of 10.35. 10.35 what? Yeah? Chris?
10.35 meters per second.
Exactly. This was 200 meters. This was 19 seconds.
Oh.
When you divide meters by second, you get a speed in meters per second. So 10.35 meters per second. So that's pretty fast.
Yeah.
You
Is that-
figure there's roughly, it's not exact, but there's about 3 feet in a meter, roughly. So he's running at almost 30 feet every second. 30 feet. So 30 feet, this room's a little longer than 30 feet, but almost the length of this room in a second. He's moving. So he's very, very fast. Now remember, that's a sprint, right? It's not like he's running, 26 miles at that speed. He's just running that speed for like 19 seconds. So he can do it for a short period of time, and that's it. Okay, so it's a 200 meter dash. Okay, not like a marathon. All right. So any questions on that one? All right. So just a couple quick reminders, and then we've got a couple extra practice problems. So same thing. We'll let you guys try the practice problems. If you finish those, show us. We'll give you the homework. So try to get a binder by Thursday. Remember, tomorrow's class is going to be a little shorter.
I think that's on, the way it's written in the daily update, it says the 13th.
The 13th.
Yes,
So Thursday?
Thursday.
I'll teach you something.
Okay, thank you. So Thursday is going to be a little shorter.
So,
So,
yeah, the plan on Thursday is, guys, probably no warm-up.
yeah,
We'll probably just do 3 exams. We'll probably just do like 3 quick examples.
yeah. Probably start right after announcements.
Yeah, right at like 7:50.
Yeah.
That way you guys have all the examples you need to fill out your reference sheet for the test on Friday.
So did people get my email with the code? So you got the code to Google Classroom?
If you don't, guys, it's up there too. You can write it down for me.
Okay. First test, okay, is going to be on Friday. And I think all term we'll probably have about 4, maybe 5 tests. So we have 1 a week. Don't forget, if you sign up on the website, you get 5 extra points for the first test.
What do you mean by
If you go on the Math with Hager, that's on YouTube,
Yeah.
and you subscribe,
Oh, okay.
if you subscribe, you get 5 points on the first test.
Are you bribing us to subscribe to your channel?
What's that?
Are you bribing us to subscribe to your channel?
I just want you to go try it, yeah. Sure, we'll call it that. And then the training is Thursday, right, Mr. Roy, not tomorrow?
Yes, Thursday.
So Thursday.
Alice.
Okay, so during that training, you'll just talk about what to do when we have a lockdown in the school. That's basically what it is. All right, so let me put up the extra problems for you guys.